Good morning. I'm going to make a hopefully quick video on how to calculate percent change because it's something we're going to use a lot. We are going to, sorry, we are going to go over this in class today, but in case I move too quickly or someone is absent or what have you, I just want to have it on file for people to use as a reference. So percent change is a really nice way to analyze data because it allows you, it kind of takes out it takes away some possible lacks of controls. So for example, in the diffusion osmosis lab, this is data set number one. Warning, this is data from last year. I didn't even write the colors because I don't want you to be confusing. I don't want it to be confusing. So I don't even write the colors. This is not data that will necessarily represent your stuff because it was done at a different time. But percent change allows us to calculate what changed about the bag without worrying about were all the dialysis tubes the same width, which they weren't. Were they all the same length, which they may not have been exact? And did we put exactly the same amount of fluid in each tube, which I know we didn't? Okay. So if you don't love spreadsheets, you should learn. They're awesome. If you do, you may not even be watching this, but I'm just going to go over how to make the spreadsheet work for you. So here's our column percent change. Whenever you're going to do a formula, you need to put in equals. I guess I wasn't clicked there. Equals, and that tells the spreadsheet you're about to go. Now this is suggesting something, but I'm not even going to, it's probably suggesting based on the fact that it says percent change or whatever. We're going to put a percent parentheses. So to calculate percent change, you're going to go with the mass you ended with, so your final minus your initial, so that gives you the difference. Hi. And then you're going to divide it by your initial because you're looking at, all right, we started with this. This is what changed. How much of the original was that? What is the fraction of the original that changed? So we're going to start with our final, which is this. Now you could type in cell D4 or you could click on it. I'm going to click on it. Then we're going to subtract our initial. And then we're going to divide by our initial again. And that's important when it comes to FRQs because a lot of times they will ask you to talk about the change in a data piece. And you want to always start with where you were at the beginning and then talk about the change as compared to the beginning number. If you set it all up right too, you'll get a negative number if you had a decrease in the value or a positive number if you had an increase. Now this looks like it's already, you can see there that it says 20.47. It looks like it's already changing it into a percent. So I'm not going to multiply it by 100. That could be because I have the percent logo here, or it's just sensing it, or I could even have right here, there's a percent. I could have even had those cells formatted as percents when I created the spreadsheet. So it makes sense to me that this is about a 20% increase when it went from 12 to 15. So I think I have my formula right. All right, there you go. Now you can also take it out. Oh no, it just went right with a percent. Okay, you can decrease your decimal places with these buttons up here. And you'll see that when you play with them, it goes back to the calculated value. I'm going to go down to a tenth because that is how precise our scales were. So here's another beautiful thing. See this little circle right there? You can click and drag this down and it will now calculate the percents using that same formula, but it adjusts for the fact that we move down a row. So up here you have D4 minus C4, which is this minus this. But in this one, if you look at the formula, it's already calculated or figured out that we're talking about this data here. So it's changed it to D5. Minus C5. So it went ahead and did it. It also changed the decimal place. So you see here the different percent changes for all of the different solutions in the lab. And it's this interesting 13, 15, 14, and 16. Nothing lost any mass here. We'll talk more about the meaning later because I just want to leave this as just percent change. All right, guys, I hope that helps and let me know if it doesn't.